finally live from downtown Mill Bay. Okay, Notebooks out. We are starting off with the 6 different types of chemical reactions. Now that we've done nomenclature, we can start putting together everything and recognizing entire reactions, as well as balancing and predicting products. The 6 different types of reactions we're going to focus on is first is synthesis. Then we have decomposition. Single replacement. Synthesis, if you took this at another school, I know some places will call them combination. I don't know if you would have done it yet or not, but combination reaction is another word for synthesis. Single replacement, double replacement, and then a special type of double replacement called a neutralization. Or acid-base. And then last one, combustion. We're only going to consider combustion where we burn carbon compounds, oil, gas, sticks, sugar. You can have combustion for all sorts of things and get all sorts of different products, but we're going to narrow our focus to the most common combustion you have, which is like literally a forest burn. There are a lot of different ways to classify chemical reaction. If you go into organic, you'll find there are literally hundreds of different types. We can classify them by the way they approach each other and what they look like. We can classify them in terms of what their electrons are doing. This particular way of classifying them is fairly useful for the types of reactions we do in Chem 10, 11, and 12 for predicting their products. So one of the aims is this, so you can look at the reactants and predict what the products are doing. Yes? Acid base, yes. Oh, did you come in late?
Yeah.
No, it'll be sad. Yes.
Will this be on our?
Oh yes.
Are we going to be in the lab for CrossGrade 2?
In the lab?
Like, will we be doing like assessments in the lab, or is it just pencil?
You'll be here in the classroom. Yeah. Okay, decomposition. I'll see if there's another copy of. Extra copies. People took extras last day. Others okay. Oh no, more over here. Okay, decomposition. First one is the classic one. Does anybody know what is the name of that one?
Can I try it?
Yeah, no. You have a nomenclature, you have a data booklet. Pull out your data booklet. Good review for naming. Where is it? We got the sodium. Sodium bicarbonate. Sodium bicarbonate or bicarbonate of soda. You may see it labeled in your kitchen. This is baking soda. And this is what gives, you put that in at approximately, I think it's about 110 degrees Celsius. It breaks down into sodium carbonate, water, and CO2. And these are what give your bubbles in your cookies. and cakes. So it provides texture to your food, and that's why we add it. We used to use ammonium in some cases, like an ammonium chloride. That would break down and dissipate and give off ammonium gas. It would smell horrendous in your oven, but it would add bubbles to the food, and the ammonium gas would actually disappear into the atmosphere, and then it would be gone. But it smelled awful. People didn't like it, so they switched to sodium bicarbonate. Some people still prefer the ammonium compounds to give their food bubbles, because you're left with this, and sodium carbonate actually doesn't taste very good. But the little tiny teaspoon that's in there, most people don't notice unless they're very, very careful. This is a decomposition. So a decomposition is a compound that is broken down into individual elements or smaller compounds. I am going to go grab a demo for one right now. Do we still have? Yes, we do. And we'll need to put on the soil. Because on Halloween, I managed to capture the ghost of Halloween.
What it breaks down to.
Yeah, but this is just like reactions that he gives.
Okay. It's not well known, but ghosts are actually soluble in water. So when I captured the ghost of Halloween, put it in there. Put it on there. As well known, if you wear tinfoil on your head, protects you from ghosts. Hence the tinfoil, keeping the ghosts out or inside. But now I can release it. Now if I take it above a little bit, you can see it rising and boiling in there.
Is the tinfoil to be reflective?
Pardon?
Is the tinfoil reflecting the heat back or something?
No, that's just to hide the trick. Obviously, it's not really a ghost in there. What it is I hit a catalyst at the top that I tied to a piece of string. The piece of string, the catalyst, when I pull the top, drops into what looks like water. What looks like water isn't actually water, it's hydrogen peroxide. And H2O2 breaks, it's literally a chemistry. Goes to H2O and O2. H2O2, no, this isn't balanced. What do we need to do to balance it?
2 H2O.
Yeah, that would work.
And then you change that to 4 to 2 H
Yeah.
2 O.
You have to
So that
put two
change the coefficient.
water.
There. So we have what turns out to be two things going down to three things. This is a decomposition. So a decomposition is some sort of A, B, C, D, amount, X, Y, whatever it is, going to A2 plus BC plus D. It is a breakdown of a compound or a larger compound into a bunch of smaller things, usually much simpler compounds like water and their individual elements. That's a decomposition. The demo you can look up online. I think originally they called it the magic genie because you get smoke to come out. So when you're looking at something and you're trying to predict what it's going to make, if I say it's a decomposition, and I say it's H2CO3, and you have to predict some products, what are some reasonable products for the breakdown of H2CO3?
Hydroxide?
Hydroxide might be, yeah, but there's an H and an O, but there's some simpler ones. H2O. We've got H2, we got O there. We got to do something with the leftover carbon though.
CO2.
CO2 would be entirely reasonable. In fact, that's actually what comes off. Now, if you looked at that in grade 10 and went, I think hydroxide, and let's see what's left over, carbon plus oxygen gas. That's not what's given off, but that's a perfectly reasonable guess at this particular stage. You're looking for reasonable things that you know exist that take into account all the elements that get given off. Anybody still ready? Still ready? Yeah, I think there's one around the corner. Good. Scream if not. Synthesis, entirely the opposite. Oh, did I forget a thing down below? Oh! That's because it's a thing. It's like a marriage.
Wait, what is...
Sorry, you have now volunteered by pointing that out, so come on up. If you don't know, you have to come all the way up. And excellent, because I got your card deck last time, so I'm just going to pick on you. Stand on the opposite side.
What's a Maui?
A marriage. A marriage is why we're here today. How can you not know about marriage? Anyway, the snowball was originally a dance, and so you would have two prevalent students at the snowball dancing. Dance.
Oh,
You have to,
Start dancing.
you have to dance. And then they would gaze
Together.
across the room and lock eyes and come together, and then obviously get married. Thank you. Please give them a hand for that very awkward interaction. Oh, no, not that one. Why do I say marriage? Because one of the greatest films of all time. Not that one. Marriage. There we go.
You read it incorrectly.
Oh, they do it. I believe it needs an I.
Today. Marriage.
It makes no sense out of context. I highly recommend you watch the movie. If you haven't watched it, you are so lucky because now you get to. And what was the other one? We're already doing that. Oh, I'm probably going to get copyright struck because I just played that. Apparently, these two got married afterwards. This is live tweeted. A guy waited until they were on a plane and they couldn't move seats to break up with his girlfriend. And so a nearby person recorded the entire thing and live tweeted it back when it was called Twitter. And then at the end of it, it turns out they proposed and got married.
What?
Yeah.
Can I watch it?
No, it's not. I put it up there because it was the dumbest thing I could find involving marriage. So they broke up, decomposition, but then they got married. And so this one, sorry, I got confused because of marriage. This one's not like marriage. A decomposition is like a divorce. Yeah. You know, when your parents call you into the room, and then one of them says, "We have something important to tell you," and then the other one says, "Yeah, we're raising your allowance," and then the other one says, "That's not what we agreed on saying, Harold." Maybe that was just my parents.
What?
I'm kidding. I'm kidding. Synthesis is like a marriage.
Wait, so should I write knowledge or marriage?
Whichever one you remember. Maybe you could write it like with a strong Scottish accent. Synthesis reactions in which you have two things coming together to make one thing. What's a reasonable thing for H2 plus O2 to make? Yes? Water. Well, we've already got oxygen gas. They come together to make water. This is the one, now we've already done this reaction. This is the one we did in the balloon and went bang.
That's not balanced.
And it's not balanced. How would you balance it, Julian?
Do it again?
2H and 2H2O.
Two there.
So three things coming together to make two things. We have a joining together inside a, it goes bang. What is the organelle in which photosynthesis happens?
The mitochondria.
That's the opposite.
Chloroplast.
Chloroplast. So you have a bunch of things going to make one thing. That's a synthesis. That's a marriage. That is everything coming together. If you get, you could have copper, solid, so we got metal, plus chlorine gas, making copper 2 chloride.
What does that blue thing say?
This one?
No, above.
That one?
No.
That?
Yes.
Light blue, chloroplast.
Can you do your little
Do, 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 do.
the mark again that's turned into an actual word?
Oh! Thought you wanted me to sing and dance.
Hell no.
Where does that
Chloropabust.
See, yippee, we got him.
Luckily, there's no evidence it's been that way the whole time.
Video.
I'll have to go. I'll have to go change that later. Did I spell chloroplast correctly? Is there? There's no e in the end. No.
Wait, what is this thing in brackets?
There's no t.
bang?
What?
It just means what bang?
There's a t. Yeah. Copper solid plus fluorine gas makes copper 3, not chloride. This is Neufeld high. Copper solid plus chlorine gas goes to copper 2 chloride. Copper solid plus fluorine gas actually reacts further. It'll give you copper 3 chloride. So it'll take an extra electron off of the copper commonly because it is more electronegative than the chlorine is. This one is, of course, balanced. This one isn't. How would we balance the second one? 2 on everything?
No, sorry. 3 on fluorine. 4 on grass. 2 on copper.
There we go. Oh. Is yours off the page like that?
No.
Oh, weird. Combination synthesis reactions involve 2, that's not actually 2, or more elements, compounds that react together to produce a larger compound. Often 2 simple things, 2 elements coming together to make a larger thing. So if you see 2 elements, what would they make? So if I gave you, as an example, it's the cross grade, and I go aluminum plus, where did chloride? Let's go bromine gas. Br2 gas. It's aluminum solid, so just aluminum metal. What is the most likely compound from that reaction? Yes.
I had a question.
Oh, I was gonna, you can give me the answer, but yes, go ahead.
Does that, like, orange before elements and compounds? Like, I don't know what that says.
Oh, it says or more. Let's see if I can.
Is that an I or a bracket?
Oh, that's a bracket.
Oh.
I'm about to see if it can also text recognize that and save myself. Ha! Look what it text recognized. Or more.
So is that one line before the or of brackets?
It's a bracket. Obviously, it's a bracket. I really don't know what your problem is. I have the neatest handwriting everywhere. My mom told me so. Yes.
Your mom likes you.
Bromide, but it's AlBr3.
AlBr3. What?
Aluminum is a charge of +3, bromide is a charge of -1.
Right.
It's also not balanced.
It's not balanced. So aluminum is +3 when it gets rid of its electrons. Bromine is -1. Over here, they don't have a charge. Bromine's going to accept electrons from the aluminum in order to get a charge. Aluminum's going to give them up, become positive. This one's going to become negative. You can look up on your periodic table. These both don't require Roman numerals. We know that's plus 3. We both know that's minus 1 when it reacts, and we can predict that particular product.
What's that line before the AL plus 3?
Oh, another bracket. Sorry. But you don't need to write that down. I was just showing you where the ALBR3 came from if you need it. No, I thought someone had their hand up over here. Nope. So, little elements coming together to make a bigger thing. If we were to put it in generic terms, I ran out of spots in the box up here. Let's do it here. A plus B goes to AB of some kind. I'm going to flip back. Decomposition. AB goes to A plus B to make it simple. And now the one you did in the lab, you didn't do this one, but you did do this one. You did copper, nope, yeah, copper chloride plus aluminum. If you have iron with copper sulfate, what are your products? I think we need another demo. Need to go with shirts, maybe. Sweaters. Excellent. Julie, you're wearing the sweater, so it works really well. Yes, unusual jacket. Perfect. Over here. Oh, no, not you. Oh, no, not you. Excellent. Join hands. Yeah.
Both hands?
Oh, sure. I wasn't going to go there, but if you're like right there, then okay. Well, hey, we're once again at the snowball. Dancing together. Excellent. Now you come in, suave, and you're going to cut one of them out. By placement of sweater, which one is going to be cut out? Okay, go. And then the other one goes away. The correct one goes away. No. You both have the same sweater. So replacing same sweater. Come in here, and then Julie, you could walk that way. Look a little sad. Excellent. And now this is called a single replacement. An element similar to the other element replaces it. Please give them a hand for that awkward interaction. So, of these two things, which is iron most similar to? Copper. So it's going to kick out the copper. So you are going to kick out the copper, and you're going to get copper by itself. Sad, lonely, walks away. Plus iron sulfate. The iron could go FeSO4. You could get Fe2SO4 3. That would still be reasonable because iron can be +2 or +3. It could theoretically also be +1. As long as it's something reasonable, that's fine, but that would be entirely reasonable. The reaction you did in class was actually copper being replaced by aluminum. And then you had what people in some cases described as rust or brown colored solid coming out. That's the copper. Now this one's a bit more unusual. The potassium hitting H2O, which is it going to replace? The H or the O?
The H.
The H. When we write compounds, we write the most positive element first, which means of those two, it's more likely to replace the H than O, because potassium itself is very positive. It goes to +1. Hydrogen can also go to +1, and so it will replace it, and you get... Now, if you replace the H, what do you get as a product?
Potassium oxide.
That would be reasonable. K2O plus
Hydrogen gas.
hydrogen gas. Yeah. You don't commonly, but I'd probably accept that. It helps if you think of water as hydrogen hydroxide, because if it's acting like a metal and popping it in, if you pop that out, you would get KOH. Whoops. I said the right word, which was KOH. Plus H2. It only pops out the first hydrogen, the hydroxide remains. We'll do that as a reaction later. I wanted to preview it now. After our cross gradient. Yes?
How did you get on the second one? How did you go from 2 to 3?
These things don't care what they started out as. So all of those, just like naming, depends on the charge.
So how do you know?
What's the charge on aluminum? Yeah, open it up. What's the charge on aluminum? +3. So I'll write it in ghost letters. This doesn't have a charge right now, but when it gets a charge, we know it's going to be +3. Ghost letters, barely visible. What's the charge on chlorine? -1. And so we know that chlorine is -1. It's here, right here. What charge must be that copper? Doesn't really matter too much because it's going to copper solid, but it's easy. +2. So that's how I knew this is copper 2 chloride because of that +2. So we know when it mixes, it's only CuCl2 because copper is +2. But because aluminum is +3, now I'll write it in a darker color. Aluminum is +3, you need 3 of the chlorines. So how many there are depend on their charge, not how many there were before. You fix how many there were before and the charge by balancing. I waited until you nodded, but I'm not entirely sure you believe me yet. We'll do a few more examples like that. First, I'll put in this. Element reacts with a compound and two of the elements switch places. All of the ones I've given you have shown a metal. So I'd like to do one that shows, this is like cutting in at a dance. We had the snowball. We could have something like, I'll take the aluminum AlCl3 plus fluorine. Predict the products. Attendance, there we go. Any predictions? No, I've already heard from you twice. Remember, types of sweaters. Is fluorine more like aluminum or chlorine?
Chlorine.
So which one's it going to replace?
Chlorine.
Right. Now the charge on chlorine is minus 1. What will be the charge on the flooring? It's 0 here, but what will it be? Minus 1. So they're going to replace each other one for one. There's no difference in charges. We don't have to worry anything. Aluminum is always, we've already established, plus 3. So what will the new compound be? AlF3 plus Cl2, because both of them are the gases that like to dance in pairs. And so that's our final compound. It's not balanced.
Mr. Newford,
Yes.
is it okay if I like did it the other way? Or does that have to be this one first?
Oh, it doesn't matter. Like math. A plus B equals B plus A. The order in which you write those between plus signs doesn't matter. Just don't forget your arrow.
Okay.
So when we're looking at a single replacement, it's AB plus C goes to AC plus B. It replaces one of them. Which one it replaced depends on which one it is most similar to. Good. Look at these. Check at whether they're synthesis. So designate them synthesis, single replacement, or decomposition. You just write next to them S, SR, or D. That's a D, not an O. Before someone complains. Sorry. And work with your partner next to you, or in a little group, whoever's right there. And whip through those. I'm going to ask people in just a minute. And I'm going to go get the next demo, which is so amazing.
Wait. Isn't it already done?
It's see a name which type of reaction it is. And there's 3 types of steel. This one,
Where?
it was the F that replaces the Cl. So which one is that that was the No, we've done these so far. Synthesis, single replacement. Yes. So right there. So it's single. Because synthesis is when they're choosing just like this one, the third one. When you have CR and I2 and it becomes like they combine. This one is when it breaks down.
Wait, what breaks?
The compound breaks down into other compounds. This breaks down into that.
Then synthesis is into then the form.
Wait, so this is single replacement.
Word.
Quarantine all over that same, and you get success.
Word. Hey Siri, set the timer to 1 second.
1 second, starting.
It was just beside my computer.
That was a pretty good
Have you
idea.
ever asked Siri where it is?
No.
If you do, you know what it does?
What?
It says, I'm here in a quiet voice and says nothing else. If it can hear you and you say set the timer to 1 second, it will then play the alarm until you find it.
I can't. Whenever I say "Hey Siri," it doesn't work.
Oh,
Oh,
you
when
do?
I can't find it, I just have my watch and then I can do that.
I don't have a watch. Okay, Anders is in here. Caden is here. Darren, Esther, Hillary, Jennifer. Yep. Jojo, Julian Chen, Julian GG, Liam, Lucas, Mirhat, and Mick, Oliver, Pablo, Riley, Vienna, and Zach. Okay, let's starting with the first one. Julian Chan. What's the first one? Single replacement. Good. Actually, what am I doing? 1, 2, 3, 4, 5, 6, 7. I'm going to call out 7 names. 2 people at a time can write. There's 2 pens there. First come, first serve. Why was that so loud? Mick.
Do we get points for this?
Jojo. Yeah, you get points for this. Come up. Designate one of them. Julian GG.
I can get a point because I already answered.
Yeah, you already got a point.
Go.
Darren.
Should I just write D?
Yeah, you can just do the shorthand. Caden. Jennifer. Currently Jennifer's winning with 9 points. Well done.
How many points do I have?
Random. Jojo.
I think I'm going class.
You have 2 to do. You got
Huh?
randomly picked twice.
What the fuck?
No, language. I'm going to say now you have 3 to do.
There's only 2 left to do.
Okay. Did I call too many people?
Yes.
Okay, you just do those 2 then.
I'm stupid. Let's
No,
see.
no, no. You
The
have,
replacement?
yeah. Oh, what kind of replacement? Put SR. There you go. Because we're going to do a different type.
And that-
Big thing, going to multiple things.
D.
There
No.
you go. D,
Yeah.
decomposition.
Oh, no.
Not a, that's okay. Just write D beside it. Done.
And that's
Okay. Below each one, please put away the book in your bag so it's not distracting and you don't accidentally pull it out. I say accidentally. I'm going to just write underneath it the how you recognize it. So you have something here that is a big thing. Going to many things, of course, that's a decomposition. You have 2 things going to a big thing, synthesis. You have a big thing going to 2 things. It's actually 7 things and 2 things, but you see, decomposition. You have 2 things going to a larger thing, synthesis. Ooh, a double thing
Can you go to the bathroom?
going to another thing, and it replaced one of them, single replacement. Julian, you can always go, reminder to everybody, you don't have to announce. I heard a phrase the other day, I really liked it. It's not an airport, you don't have to announce your departure. That deserves no applause. One thing with a pair replacing it, single replacement again, 2 things, synthesis. Now, we have 1 thing going to 2 things. What is that? No, all together. 1 thing going to 2 things? Oh no, you gotta say it more excited than that. That wasn't a chorus. We should practice singing. Lucas, what is this one? We have 2 things going to just 1 thing. single replacement would be a pair say. So you always have, for a single replacement, you always have two things on both sides. So it can't be that. Where do you have two things coming together to make a larger thing? Look at all the other examples. Pardon? No, just say it louder because literally I have a partial cold. I can't hear you. Decomposition. Big things coming together make a larger thing. So it would be a decomposition if it went the other way. Decomposition is falling apart. So which one's coming together? Synthesis. Don't worry, to help you get this, you're my next volunteer for the next demo. Well done. Excellent. Because the next one's going to be double replacement reactions. Now, you're wearing that type of sweater. So, but I only need two, so yeah, that would work. Come on up. And then we need two other similarities. Now I've used sweaters already, so they've already been used. Oddly colored jacket. Anybody else wearing an illegal hoodie? Anybody have a hoodie with it? No, that's not going to work. What are you wearing underneath your hoodie? Polo shirt. We probably got lots of polo. Everybody has to be wearing a polo. Is that the sweater or the polo shirt? Oh, no, another sweater. A lot of volunteers. Pardon? Yeah, I don't want to pick on the same person twice. So, and we have a white polo. So that would be unusual. Anybody else wearing a white polo? Oh, but you've already been up. Red polo? Oh, Riley's wearing a red polo.
I'm wearing a red polo. I'm in black polo.
Unusual sweater.
Unusual sweater?
Super usual sweater.
Unusual sweater? Unusual jacket. Let's go. Come.
Jacket's a hoodie.
Hey, hoodies or jackets? Come. Yeah, unusual sweater. Now, you have to separate together. So, similarities, unusual jackets, similarities, Brentwood logo, joined, because we're at the snowball. Joined, excellent. Dancing. Now, and this is the hard part, switch partners correctly. Excellent. I have done that demo where they both switch partners and then they end up with the same person at the end. That's why I have to say it correctly. Now, dance. Notice in this one, everybody's happy. They all have a partner there. Please give them a hand for the very awkward demo. Thank you. Because with the other one, I couldn't quite show like which one's going to replace which one, but for this one, I can. If you have a compound AB and you have a compound CD, which one is A going to replace? C. Why C? How does it look like? How do you know just by looking at it? It comes first. We have a metal, and we'll replace it. Ooh, more pickles.
This is delicious. This is the last one.
Oh. Whose is it?
Mine.
Oh, whoa.
Did you make it?
Yeah.
Is it a pickle?
They're
It
very
is
good.
very good.
You should bring some next time you're in GE.
How was the field trip?
Fantastic.
What
How's
cost
passing
is this?
out?
Fermentation. We're doing biochemistry
No.
right now. Oh, low
Advertising for them. Which class should they take?
Oh, Life Science 11.
Life
Yeah,
Science
look,
11
yeah.
if you want to make pickles.
Yeah.
Can we make pickles?
So given that, what are our two products?
A, D, and B,
A, D,
CB.
and not D. Sorry. I heard you say D there. A, D, and what? C, B. Can you write BC?
No.
No. Why not?
Order.
Order. Tradition. Order. What do you mean by order?
What?
What do you mean by order?
Like the similarity.
Yeah. I mean, you're right, it's order, but how do you know C comes first? I may have posed this in a way that's too tricky. If it comes first on this side, it has to come first on that side. I'm just trying to avoid students who will write it, because this is first sort of over here, they'll just go BC. You actually have to put the one that's first in the compound because it's a metal and a non-metal in most cases. Two compounds reacting and switch partners. Positive goes with negative. Apparently, I was teaching last year and someone from Alberta was here, and they said this is like line dancing in a country and western song in which you switch partners. I have never done that, so if you're from Alberta,
That's just,
does that make sense?
there's this
Excellent.
in Scotland.
In Scotland, you can't just say in Scotland and trail off.
There's a dance like that in Scotland.
What's the dance called?
It's like, I don't know. I'll find a video.
Julian, your job now is to look up the dance, provide the video.
Now?
Yes. No, not right now.
If you had two covalent bonds,
This is an ionic reaction.
it could never be covalent.
If it's covalent, it's by accident. So you may see something looks similar. It's not this type of reaction. This is ionic. So you have two ionic partners.
Single replacement can be covalent, though, right?
And single replacement is one ionic and then usually one covalent. One covalent if it's a non-metal, or the other one could just be a metal. So it's either or. It's just an element. Second to last. This is a very special type of double replacement. It helps to see the double replacement if you write this as HOH again instead of H2O. Essentially, a base and an acid react to make water and the equivalent salt. The salt is made up of the metal, of the hydroxide base, and the non-metal of the equivalent acid. So you end up with HA plus BOH goes to HOH. And BA. That is the salt. This is the water. This is the acid. This is the base. The acids can be a little complex. They can have polyatomics. This is one of the ones I asked you to know. Sulfuric acid, H2SO4. So we have the H, sodium hydroxide, which I meant for that to be in blue. Sodium hydroxide, which is a very common base. It's known as lye, featured in the movie Fight Club. Making our water. And then we put together our metal and our non-metal. Sodium, what's the charge on sodium?
Plus 2.
+2?
With a minus.
Sodium. +1. What's the charge on sulfate? -2. Crisscross Na2SO4 and we get the equivalent salt. Okay. The thing you're looking for an acid base is an HOH making water and then the other parts joined together as the salt. It's a special type of double replacement. It's used and reacts everywhere. It's particularly important on planet Earth. A lot of our reactions are acid-base reactions, and they affect our chemistry, they affect our biochemistry. Your pH is very tightly controlled. Have you ever heard of like the acid diet or the base diet, and you're not allowed to eat certain foods because they're considered acidic? If you have heard of that, that is nonsense. Your kidneys are really good at regulating your pH. If your pH rises or falls by 0.1 of a pH, you will die. And if it wasn't tightly controlled, if you could affect your pH by eating food, more people would be in a lot of trouble. It is possible. If you do a keto diet to the point you literally manage to eliminate every single carb, you can put yourself in what's called acidosis and give yourself acidic blood. But you need to be really good at doing that and do that for a little while, for a number of days. Your breath will start to smell like acetone, like nail polish remover, because you're making acetones as well as going into acidosis. Don't do that. Even if you're on a ketone diet, not a ketone diet, a low carb diet, it's low carb. It's never zero carb. Yep.
Will you die?
So just for
Yeah.
this one, is it more focused in neutralization or double replacement in multiple choice?
This is a special type of double replacement, so you need to know this as a neutralization.
In a multiple choice question, if both were
It's a neutralization.
okay.
Yeah. It's special enough on planet Earth. If we were an ammonium-based chemistry, we probably wouldn't care about it quite as much, but it is particularly important for water-based life forms. Now, there's a lot of hearing about acids and bases. We're going to skip that because I'm going to do that as a lab later, after the cross-grade. There's one more type we're going to do, but before we do that, I want you to just check. This is it a neutralization? So you just yes, no. Now you can put what other type of reaction in there, synthesis, double replacement, if you can identify decomposition, but lots of reactions will produce water, but aren't neutralization because they don't have an acid and a base in them. So this is just making sure you can see the pattern of acid and base. Give you a minute to do that one. And I'm going to do the demo. I just realized I forgot to do of the double replacement.
Water and a salt. Basically, if it has water and something else, it's probably a neutralization.
Oh, and you get the other demo too. Yep. Test? Next week? Ours is on the
This one's wrong. You need an OH and an O. You got it.
there. C. Assembly. Grade musical. Hmm.
Does all of them matter?
Oh, I see.
If it's like something forever, if it's like
Are there a lot of Jewish holidays?
There might be. What? Yeah, we can do that. Send me an email and I'll get it set up. Yep. No? Oh, I know people who are Jewish, and sometimes it's important to know when the holidays
Here,
are.
here, now you know another one.
Yeah.
How do you actually get all the major dates and all that stuff in the calendar? Because when I tried clicking on it on the website, it didn't allow me to add sync or anything.
Sorry, what?
I don't know if I brought the major dates from the website, it just didn't allow it.
Oh, come see me. Maybe a tutorial. I have a bunch of people coming to tutorial. That's more of a tech question. But I can help you with that. I've done it. Okay. If I could just go through, is this an acid base or not? You can just say yes or no. But if you can identify the type, I'll ask a follow-up to the class. First one, Darren, is this an acid-base equation? Oh, hold it. Where'd she go? Oh, escaped. Julian, GG. Acid-base? No. Does anybody know what that is?
What's the difference between?
Yes? Synthesis.
Oh, we have to write that as well?
You don't have to, but it's now that we've done all the other ones, it's useful to know. Next one. Vienna. Is that one acid base? Yeah. Why? We've got an H. We've got a salt, but we're missing one piece. What else do we need with an acid base? Pardon? We need water. So you'd need an H2O here, and you need an OH somewhere. So it is actually not an acid base. This is a double replacement. What probably fooled you, this is in fact an acid, but there's no base in there. It's not an acid base. It's a double replacement. Pablo, is this an acid base?
Yes.
Why? It has water, so we have that. It has a salt, it has H, and it has OH. So, yep, that's an acid base.
Should I say the type?
It's acid, it's neutralization. This acid base is also the type. Liam, is that one acid base?
No.
No. Why not?
Because it's decomposition.
It's decomposition. We have one thing going to two things. This is an acid, but it doesn't have a base. Is this one acid base? Julian's? Oliver? No, why not? Yeah, the H2O is on the wrong side. It does have an acid, but it's on the wrong side. Next one. Is this an acid base? Whoa. Is this an acid base? You just volunteered. I hadn't even called a person out. Yes, why? Pardon? You're right, it is an acid base. What are the essential elements? It's got the H. It's got water. It's got the salt. Like if we make this A and B, then we have our AB salt. And we've also got the OH. We've got a hydroxide and so that's the base, that's the acid. We also have our salt. So that one is an acid base. There's one last type of reaction. It is my favorite type of reaction. I need a data booklet for this type of reaction. And this reaction is my favorite because it comes with song. And then you can feel the burning. And then you hear the voices. And then you say, no, we can't burn the whole school down. Just the paper.
Physically, we could build.
But we could build a new school. And
Already done that.
this would be, and it's so pretty. Also, I always been fascinated when I'm burning this, and you probably can't see it from there, but as it's burning, in addition to the smoke, the ink doesn't burn. The ink stays. The ink actually has metals and other things in it, so that ink actually doesn't go away. You can read it in the ashes, which is so cool. Also, burning things is just fun. Yeah. I grew up on a farm with access to gasoline and diesel fuel and high nitrate fertilizers. We got sulfur from the train tracks, saltpeter from the store, also glycerin. So we were able to make both dynamite and nitroglycerin. Sometimes rural places are nice to grow up. That reaction is a combustion. But no, this is my joy. My joy.
Can we do that every year when we're done before?
In terms of recognizing, it is always some sort of thing, and this is constant. You always have oxygen. Different color, please. You always have oxygen. You always give off water, and you always give off CO2. For a carbon combustion, that it will always be the result. So if you have sugar, C6H12O6, react with oxygen, gives off water, gives off CO2. You can rely on it always having those three parts, so it's one of the easiest ones to identify, because you will always see reacts with oxygen, gives off CO2, gives off water. I said we're only doing those types, so it'll be the simplest types. But if you had things like sulfur and nitrogen in there, in addition to CO2, you would get like NO2 or N2O4 and SO3 and other gases that also have oxygen in them. But we're only going to do the simplest type.
Under test, will you make us predict the
You might. Yeah, you might.
How long is this test going to be?
It's going to take up the class. We don't have like an exam hall where you write like 3-hour tests in the middle of the year. So it'll be class. Yep.
So what's going to be like the difference between the ground schools and like?
There is no difference. It just means multiple classes are taking the same test. Yes.
Can you make like a summary package in a way it's like
That's all your notes so far. I will post some review things online as well, but your note packages are a complete list of everything. You're also going to get a new practice worksheet for this section, and that's the last one. Yes, it is everything from September. It is your chance to improve on every single section that you've done for all of those who have done the other things. You weren't here, so yes, you need to get those. They're on the Google Classroom. You're going to print them off. You also can get them off of someone else in the house.
How much is this test worth in work rate?
an infinite amount. You should study for it to the exclusion of all other courses.
When did they say we would be able to look at our grades?
I have no idea what
Swear,
this is.
because I remember saying this last
The
time.
18th, Monday.
Um,
That's so sick.
Okay, that is the last thing. I'm gonna go grab your worksheet on that. I'll stop.